This section is on spheres and hemispheres. In this section, you will learn how to find the surface area and volume of a sphere. You will learn how changes in the radius affect the volume of a sphere. You will also learn how to find the volumes of irregularly shaped regions by adding or subtracting their component parts. Here are some formulas you will need. The volume of a sphere, V, equals 4/3 pi r cubed. The surface area of a sphere equals 4 pi r squared. The volume of a hemisphere equals 2/3 pi r cubed, while the surface area of a hemisphere equals 2 pi r squared. Here's example 1. The radius of one sphere is r. The radius of a second sphere is twice as long. What is the ratio of the volume of the smaller sphere to the volume of the larger sphere? The volume of a sphere with radius r is 4/3 pi r cubed. If we double the radius to 2r, we get 4/3 pi, and then we're cubing 2r. When we do that, we get 4/3 pi times 8r cubed, and going through the math gives us 32/3 times pi r cubed. Now to find the ratio of the smaller to the larger sphere, the wording tells us to place the volume of the smaller sphere in the numerator and the volume of the larger sphere in the denominator. This gives us 4/3 pi r cubed over 32/3 pi r cubed. You can see right away that the pi r cubes cancel. Similarly, the 3 in 4/3 and in 32/3 will also cancel. This leaves us with 4/32, which reduces to 1/8. Example 2. A ball is packed in a cube-shaped box. If the ball has a radius of 4 inches and the ball just touches the top, bottom, and sides of the box, how much empty space is left inside the box when the ball is in it? Hint, if the radius of the ball is 4, how long is the side of the box? Two things to know. The empty space in the box will equal the volume of the cube-shaped box minus the volume of the sphere. And if the radius of the ball is 4, the side length of the box will be twice that, which is 8. The volume of the box is s cubed, which equals 8 cubed, which equals 512. The volume of the sphere is 4/3 pi times 4 cubed. 4 cubed is 64. Hence, we have 4/3 pi times 64. This gives us 256/3 pi. Therefore, the area of the box left over, which is the amount of empty space in the box, is 512 minus 256 pi over 3. However, it's not that simple because the SAT will give you an answer in one term only. That means that it will all be over the same denominator. The common denominator is 3. Therefore, to have an equivalent fraction, we need to multiply 512 by 3. This will give us 1,536 minus the 256 pi all over 3, which is our answer. In example 3, a silo is made up of a cylinder covered by a hemisphere. The radius of the cylinder and the hemisphere is 10 feet. The entire silo, including the hemispherical top, is 30 feet high. What is the volume of the silo? The trick to remember is that the height of the hemisphere is the same as its radius, which is 10 feet. If the entire silo is 30 feet tall, then the cylindrical portion of the silo is 20 feet tall. To find the total volume, add the volume of the cylinder to the volume of the hemisphere. The volume of the cylinder equals pi r squared h. Recall that the radius is 10 and the height is 20. This gives us pi times 10 squared times 20 equals 2,000 pi. The volume of the hemisphere equals 2/3 pi r cubed, which is 2/3 pi times 10 cubed, And doing the math gives us 2,000 pi over 3. The volume of the entire silo is 2,000 pi plus 2,000 pi over 3. Notice that we will need to get this into one term, which means we need a common denominator of 3. We can think of the 2,000 pi as having a denominator of 1. We multiply top and bottom by 3. This will give us 6,000 pi over 3 plus 2,000 pi over 3, which will add to 8,000 pi over 3. In example 4, a factory makes balls with a radius of 3. How much material will it take to make the outer covering of the ball? This is just a way of asking you for the surface area. The surface area of a sphere is 4 pi r squared. We're told that the radius is 3. Therefore, this equals 4 pi times 3 squared, which is 4 pi times 9, or 36 pi. Here are some practice problems for you to try. Pause the video after each problem. When you have finished, come back for the answer. In this problem, a factory makes children's beach balls with a diameter of 10 inches. Find the amount of material needed to make the ball. For the ball in problem 1, what volume of air is needed to fill the ball? Here they're simply asking you for the surface area and the volume of a sphere. All you're doing is plugging into the formulas. And the answers to problems 1 and 2 are as follows. The surface area equals 4 pi r squared, which is 4 pi times 5 squared, which is 4 pi times 25, or 100 pi. The volume of the ball is 4/3 pi r cubed, which is 4/3 pi times 5 cubed. This becomes 4/3 pi times 125, which becomes 500 over 3 pi. The only trick to doing these problems is to remember that the diameter was given as 10, and you must take half of 10, which is 5, which is the radius of the ball. You can only use these formulas with the radius and not with the diameter. Problem 3 is a challenging multi-step problem. Charlie gets a job maintaining the city tennis courts. He collects the abandoned tennis balls and brings them home for his dog to play with. He stores the balls in cylindrical containers. A cylindrical container with radius r holds 3 tennis balls. The balls just touch the top, bottom, and sides of the can. What is the volume of each tennis ball? Which is A. B. What is the volume of all 3 tennis balls combined? C. What is the volume of the cylinder? Hint. Express the height of the cylinder in terms of the radius of the tennis balls. D. What is the amount of empty space in the can? Here are the answers to problem 3. Note that the trick to solving this problem is realizing that the height of the cylinder is equal to the height of the 3 tennis balls. Since the radius is r, the height of one ball is 2r, and the height of all 3 balls is 6r. The volume of one tennis ball equals 4/3 pi r cubed. The volume of all 3 tennis balls is 4 pi r cubed. The volume of the cylinder is pi r squared h. The trick, again, is knowing that the height is 6r, and this gives us 6 pi r cubed. The volume of empty space in the can is the volume of the cylinder, which is 6 pi r cubed, minus the volume of all 3 tennis balls, which is 4 pi r cubed. Doing the subtraction gives a result of 2 pi r cubed. You will recognize that problem 4 is exactly like one of the examples, only we've changed the numbers. A silo shown below has a diameter of 30 feet. The height of the entire silo, including the hemispherical top, is 45 feet high. What is the volume of the entire silo? Here's the trick. We need to know that the radius is 15, and that radius is for the silo, and it's also for the hemisphere. And that will also be the height of the hemisphere, which is 15 feet. And the height of the cylindrical part of the silo is 45 minus 15, which is 30 feet. The volume of the hemisphere is 2/3 pi r cubed, or 2/3 pi times 15 cubed. Doing the math gives us 2,250 pi. The volume of the cylinder is pi r squared h, which is pi times 15 squared times 30. The result of the multiplication there is 6,750 pi. The volume of the silo equals the volume of the hemisphere plus the volume of the cylinder. This gives us 2,250 pi plus 6,750 pi, which equals 9,000 pi.